So far, we've been working with single pieces of data, like numbers, strings, and booleans. But real-world programs often need to handle groups of data. For example, a list of student names, daily temperatures, or a list of to-do items. In Python, the most common way to store and work with collections of data is by using lists and tuples. A list is one of Python's 4 built-in data types that we use to store collections of data. The key idea here is that lists let us keep multiple values together in a single variable. For example, instead of creating 5 separate variables to store 5 numbers, we can just put all those numbers inside one list. Python actually has 4 main data types that can hold collections: list, tuple, set, dictionary. Each of these has different characteristics and use cases. We'll spend time today focusing on lists. Let's take a closer look at what makes a Python list so useful. A list allows us to store multiple items in a single variable. So instead of creating separate variables like item 1, item 2, item 3, we can put all of them together inside one container. Lists are ordered, meaning the order in which you add items is preserved. They are also changeable or mutable, which means we can modify them, add, remove, or change items after the list has been created. That's one of the biggest differences between lists and tuples, which we'll talk about later. Lists are written using square brackets. So whenever you see square brackets in Python, that's your hint you're probably looking at a list. Lists can store mixed data types. You can have strings, integers, floats, booleans, and even another list inside the same list. Let's look at the example. Here you can see that my underscore list contains text, numbers, a boolean, and even another list nested inside. When we print it, Python shows all of these elements together, exactly in the order they were added. Now that we know lists can hold multiple items, let's talk about how those items are organized inside the list. List items are ordered, meaning the order you add them in is preserved. Python won't rearrange them for you. So if you add apple, banana, and cherry in that order, that's exactly how they'll stay unless you change them. Lists are also changeable, which means we can modify them. We can replace, add, or remove items after the list is created. That flexibility makes lists one of the most commonly used data structures in Python. Another important property is that lists allow duplicate values. If you have multiple identical items like apple, apple, banana, that's perfectly fine in Python. Both apple entries will be kept. Now, one of the most important things to understand is that list items are indexed. That means every item in a list has a position number. We call that its index. The first item always has index 0, the second item has index 1, and so on. You can see that illustrated in the diagram. If we have a list C equals open bracket minus 45, 6, 0, 72, 1543 close bracket, then C open bracket 0 close bracket is minus 45, C open bracket 1 close bracket is 6, and C open bracket 4 close bracket, the last one, is 1543. This indexing system allows us to access or modify any item we want simply by referring to its position number. And remember, Python uses zero-based indexing, which means we always start counting from 0, not 1. Now that we know each list item has an index, let's see how we can actually use those indexes in Python. Here we have a simple list called fruits that contains 3 items: apple, banana, orange. Each item has its position, or index. Apple is at index 0, banana is at index 1, orange is at index 2. We can access any element we want by putting its index number inside square brackets. So if we write print fruits 0, Python will print apple because that's the first element in the list. Next, print fruits 1 prints banana, and print fruits 2 prints orange. It's really that simple. The index tells Python which element we want to retrieve. Just remember that Python indexing always starts at 0, not 1. So if you ever see an index out of range error, it often means you tried to access a position that doesn't exist in the list. We'll also later see that we can count from the end of the list using negative indexes. For example, fruits, open bracket, -1, close bracket, gives us the last element, orange. But for now, focus on getting comfortable with zero-based indexing. It's a fundamental concept in Python and most other programming languages. Now let's look at what happens if we try to access something that doesn't exist in the list. Here we have the same list called fruits, which contains 3 elements: apple, banana, orange. That means the valid indexes are 0 to apple, 1 to banana, 2 to orange. But in this code, we're trying to access fruits at index 3. What's the problem? Python starts counting from 0, so our list only goes up to index 2. Index 3 doesn't exist. When Python runs this line, it will throw an error called index error, list index out of range. This means we're trying to access a position that isn't there. It's a very common beginner mistake, especially when looping through lists or when you forget that Python indexing starts at 0. So whenever you see index out of range, think, did I go one number too far? Always double-check the length of your list using the len function if you're not sure how many elements it has. This is a great reminder that Python will only let you access indexes that actually exist in the list. Here's what happens when we actually run that code from the previous slide. Let's look at what this error message tells us. It shows the file and line number where the error occurred. Then it highlights the specific expression that caused the problem. In this case, fruits at index 3. Finally, it gives us the exact reason: list index out of range. Now that we know how to access list elements using indexes, let's look at something even more powerful. We can change the value of a specific element in a list. Here's what's happening in this example. We start with our familiar list, fruits. This list has 3 items: apple, banana, and orange. On line 2, we write, fruits at index 0 equals fruits at index 2. So what does this line mean? It tells Python, take the value at index 2, which is orange, and assign it to the first position, index 0. In other words, we're replacing apple with orange. So when we print the list on line 3, it will print out orange, banana, orange. So now both the first and last items are orange. This shows one of the most important characteristics of a Python list. Lists are mutable, meaning we can change their contents after they're created. We can update any element we want by using its index and assigning a new value. If this were a tuple, this line would cause an error because tuples are immutable. But with lists, Python gives us full flexibility to modify, replace, and rearrange elements whenever we need. So always remember, lists are ordered, lists are changeable, and you can access or modify elements by their index. Let's look at the example here. The original list starts with banana as the first item. But in the second line, we're replacing that first item at index 0 with the word apple. When we print the list, the output is apple 0.99 USD. Sometimes we need to know how many items are inside a list, especially when we're looping through it or checking if it's empty. Python makes that super easy with a built-in function called len, short for length. Let's look at this example. My underscore list has 3 items: apple, mango, and 100. When we pass the list into the len function in line 2, Python counts how many items are in the list and returns that number. So the output will be 3. This means our list has 3 elements. The len function is incredibly useful. You'll use it all the time when working with lists, strings, tuples, or even dictionaries. It's especially helpful when you need to loop through all elements in a list. We've seen how the len function works for simple lists. Now let's look at a slightly more complex one. In this example, our list contains a mix of different data types. My underscore list has apple, mango, 123, 33.33, true, and another list that has two items, orange and banana. Now, what do you think the length will be? Even though there's a list inside the list, Python still counts that entire inner list as one single element. So the total length of this list is 6. That's an important concept to remember. The length function only counts the top-level items in the list. It doesn't go inside nested lists or count their elements separately. So if you wanted to know how many items are inside the inner list, orange, banana, you'd have to call len on that part directly by saying print len my underscore list at index 5. That would return 2 because there are two elements inside that inner list. This example shows two key ideas. Lists can hold mixed data types, even other lists. The len function only measures the length of the outer list, not the nested one. So whenever you're working with nested structures, always pay attention to which level you're measuring the length of. Now that we know how to check the length of a list, let's see how we can add new items to it. In Python, the simplest way to add something to a list is by using the append method. Think of append as attach to the end. Let's look at the example. Here's what's happening step by step. We start with a list that contains 3 elements, apple, mango, and 100. Then we call my underscore list.append banana. That line tells Python to take the string banana and add it to the end of the list. Finally, we print the list, and now it includes 4 elements, apple, mango, 100, and banana. The important thing to remember is that append always adds just one element, and always at the end. If you call append multiple times, each new item will be added after the last one. All right, so we saw how to add an item to the end of a list using append. But what if you don't want it at the end? What if you want to put something right in the middle, or even at the beginning? That's where the function insert comes in. Insert lets you choose exactly where to add something inside your list. Take a look at this code. We start with apple, mango, 100. Then we tell Python, hey, insert banana at index 0. Remember, index 0 means the first position in the list. So Python slides everything over and puts banana right at the front. When we print it, we get banana, apple, mango, 100. Pretty neat, right? If you wanted to put it somewhere else, say in the middle, you just change the index. For example, my underscore list insert 2 grape would drop grape into position 2, right before 100. So the big difference is append always adds to the end, insert lets you pick the exact spot. It's like choosing whether to tack something on at the end of your to-do list or squeeze it right in between 2 other tasks. Now let's look at how to remove something from a list. One of the easiest ways is by using the remove method. Here's how it works. You tell Python the value you want to remove, and it takes out the first match it finds. So what happens here? We start with a list with 3 items, apple, mango, and 100. Then we call my underscore list remove mango. Python goes through the list, finds mango, and removes it. When we print the list, the result is apple, 100. Easy enough, right? But here's where it gets interesting. Look at the next line. We call my underscore list.remove mango again. Now Python will look for mango one more time, but it's not there anymore. When that happens, Python raises an error, specifically a value error, because it can't remove something that doesn't exist in the list. So the key points to remember are, remove deletes by value, not by index. It only removes the first occurrence of that value. And if that value isn't found, Python throws a value error. We now know how to remove an item by its value using remove. Let's look at another way, removing an item by its position using pop. Here's the cool part. Pop doesn't just remove an item, it also returns it. so you can see what was taken out or even use it somewhere else in your program. Let's walk through this example. We start with our list, apple, mango, and 100. Then we call my_list.pop. Notice there's no index inside the parentheses. When you don't give pop an index, Python automatically removes the last item from the list. So here, 100 gets removed. And since pop returns the removed value, it gets stored in the variable removed_item. When we print it, we'll see removed item: 100. Now the list only has two elements left, apple and mango. If you do want to remove something from a specific position, you can pass in an index. For example, my_list.pop at index 0. That would remove the first item, apple. So, quick recap: remove deletes by value, pop deletes by position. And if you don't give pop a position, it removes the last item by default. This makes pop really handy when you want to both take something out of a list and use it later. Kind of like saying, hey Python, remove this item and hand it to me at the same time. So far, we've used append and insert to add items to a list. But Python gives us another really handy shortcut. We can use the += operator to add multiple items at once. Let's look at this example. Here's what's happening. We start with a list that has two elements, apple and kiwi. Then, instead of calling append twice, we just use the += operator with another list, orange and banana. Python reads this as, take the original list and add these new elements to the end. After that line runs, my_list becomes apple, kiwi, orange, banana. We just saw how we can add items to a list using +=. Now let's take a look at another way, using the plus operator. This one works just like adding two strings together. It joins or concatenates two lists into one new list. Let's look at this example. Here's what's happening step by step. We start with a list containing apple and kiwi. Then we take that list and add another list, orange and banana. Python combines the two lists into one. The new value of my_list becomes apple, kiwi, orange, banana. So plus creates a new list that's the combination of both sides. It doesn't just modify the original list in place. Instead, it builds a brand new list and then reassigns it back to my_list. That's a small but important difference compared to using +=, which directly updates the existing list instead of creating a new one. So you can think of it like this. Plus is for joining two lists together to make a new list. += is for adding new elements directly to the same list. Both will give you the same visible result. But if you're writing larger programs and care about memory or references, that difference matters. One of the most common things you'll ever do with a list is looping through it. When you want to go through each item in a list and do something with it, the easiest way is to use a for loop. Let's look at this simple example. Here's what's happening. Python looks at your list. It sees three elements, apple, mango, and 100. Then for each element, it temporarily stores it in the variable called item and runs the indented code, in this case, print item. So when we run this, the output looks like this, apple, mango, 100. It goes line by line, printing each value in the list. You can think of it like saying, hey Python, for each element in my list, do this thing. That's what makes the for each loop so powerful. You don't need to worry about indexes or how long the list is. Python handles all that for you automatically. This approach works for lists of any size, even lists with mixed data types, just like the one we have here with both strings and a number. Here's another way to use the for loop. We can combine the for loop with the range function and use indexes. Let's walk through this code. Here's what's going on. The len function gives us the total number of elements in the list, in this case, 6. The range len my_list generates the numbers from 0 to 5. Those are the valid index positions. Then for each of those index values I, we access the element using my_list at index I. So when we run this, the output looks like this: 0, a white space, 1, B, white space, 2, C, white space, 3, D, white space, 4, E, white space, 5, F. Pretty neat, right? Now we can see both the index and the value side by side. This is super helpful when you need to update specific positions in a list, you're debugging and want to see the index of each item, or you want to display information in a numbered format. Also, notice that little trick at the end of line 4. End equals single white space in the print statement keeps everything on one line, so it prints neatly across the screen instead of vertically. And finally, line 5 just moves the cursor to a new line once the loop finishes. Otherwise, your terminal prompt would end up right after your last item. All right, let's take lists one step further. What if we want a list that contains other lists inside it? That's what we call a nested list. Here's an example that uses a to-do list idea, something we'll actually use in one of your projects. The first line, to-do_item, represents one task. It has several pieces of information: the due date, the priority, the description, the category, and whether it's completed or not. So this one list holds all the data for one task. Now in real life, we don't just have one task, we have many. That's why the variable to-do_list is a list of lists. Each inner list is one task, just like to-do_item. So in this example, the first inner list is the task finish project. The second inner list is the task clean room. Each of those sublists follows the same structure: date, priority, description, category, and completed status. This is a great way to organize structured data in Python. You can think of it like a small spreadsheet. Each row is a list, and each column represents one piece of information about that task. Later on, when we build our to-do app, you'll see how we can loop through this list of lists, display tasks, sort them by priority, and even mark them as completed. So just remember, a nested list is simply a list that holds other lists. It's Python's way of helping us store more complex, structured information, all within one variable. How do we then access the data inside a nested list? Let's look at line 6. What's happening here? The first index, 0, says go to the first task in the list. The second index, 2, says within that task, get the third item. So to-do_list at 02 means go to the first task, then grab the task description. This should print finish project. The line 7 shows that how we modify data too. Here we're saying go to the second task at index 1, then access the fifth element at index 4, which is the completed status, then we set it to false. So we just changed the second task from completed to not completed. Let's switch gears a bit and talk about how we compare lists in Python. Yes, lists can be compared using the standard comparison operators like equals equals, less than, greater than, less than or equals, and greater than or equals. But the way Python performs these comparisons might surprise you. It compares lists element by element, from left to right, using something called lexicographical ordering. So what is lexicographical ordering? It sounds complicated, but it's actually very simple. Lexicographical ordering means comparing sequences one element at a time, starting from the left, just like how words are arranged in a dictionary. You compare the first elements. If they're equal, you move to the next elements. As soon as Python finds a difference, it makes the decision based on that comparison. When you look up words in a dictionary, how are they ordered? They're arranged alphabetically, letter by letter, from left to right. Let's take this example. Apple is less than banana. This is true. Why is this true? Because we compare the first letters, A and B. Since A comes before B in the alphabet, apple comes before banana. So Python says apple is less than banana. Now let's look at the next example. Cat is less than car. This is false. Here's why. We compare letter by letter. First, C versus C, they are equal. Next, A versus A, they are equal. Then T versus R, now we see the difference. Since T comes after R in the alphabet, cat is actually greater than car. So remember, Python compares from left to right and stops at the first difference, just like a dictionary. Let's think about why the result is true. Python compares lists from left to right. It looks at the first elements of each list. If those are different, the decision is made immediately. Here, the first element in the first list is 1, and the first element in the second list is 2. Since 1 is less than 2, Python stops right there and returns true. It does not check the rest of the numbers. That's how lexicographical comparison works. Compare from left to right and stop at the first difference. This is also true. Here's why. Python compares lists from left to right. First elements, 1 and 1, they are the same. Second elements, 2 and 2, equal. Now the first list runs out of elements. When all compared elements are equal and one list is shorter, Python considers the shorter list to be less than the longer one. It works just like words in a dictionary. For example, cat comes before caterpillar because it matches up to a point and then ends. So in this case, since 1, 2 matches the beginning of 1, 2, 3 and is shorter, Python returns true. Lexicographical ordering means this: compare from left to right. And most importantly, the first difference decides. As soon as Python finds two elements that are not equal, it stops comparing and makes the decision right there. So don't overthink it. Left to right, first difference decides. Now that we understand how lexicographical ordering works, we will look at a couple of examples. As we go through them, pause for a moment and try to predict the result before we reveal the answer. Keep the rule in mind. Compare from left to right and let the first difference decide. Let's test your understanding. That's it for today. Next time, we'll take a look at tuples and see how they're similar to lists and how they're different.
Thank you for your attention today. This presentation was prepared by
준비.
with assistance from AI Technologies. I truly appreciate your engagement. See you in our next class.